Hello, everybody. This is Scicloj meeting number 10. Scicloj is a group of people working on open source solutions for data science in Clojure, and actually everything about data in Clojure. And today we have a special guest, Ludovic Courtès, who will be speaking about Guix-Jupyter. I'm not sure how to introduce Ludovic because he has been involved in so many projects, both in free software and in academic research. And later, Ludovic will present himself more accurately. But for now, the reason we are meeting Ludovic is his involvement in developing GNU Guile, the Scheme dialect, and GNU Geeks, the toolbox for deployment and package management in Linux, and Guix-Jupyter, the reproducible notebooks that we will be hearing about today. And I think if it is okay, Ludovic, would you like to present yourself a little more?
Sure.
Yeah, thank you.
Okay. Well, thank you for the introduction, Daniel. Everyone can hear me fine? Yeah?
Yes.
Okay. So, well, thanks a lot for having me today in this web meeting. I'm really pleased to be able to talk with all of you people. I'm not a Clojure person, at least not yet. I'm very interested in Clojure for lots of reasons. I'm a schemer, and I'm pretty sure I'm aware of many lessons we can learn in Scheme from Clojure, many good things that I've seen, and sometimes I'm a bit jealous of these things, actually, but and I'm really happy to have the opportunity to talk about reproducibility and reproducible notebooks, Jupyter notebooks, because I think it's a hot topic. So you wanted me to introduce myself, I guess, which you did pretty well. I used to work on Guile. Well, I sometimes work on Guile. I'm even officially co-maintainer of Guile, but I'm not so active these days. I spent most of my hacking time on Geeks and all things Geeks, which we'll talk about in a minute. I've been doing that for a while now, and over the last couple of years, I've been working on Geeks in the context of reproducible science, specifically on high-performance computing. So I work at INRIA, which is a French research institute, and there are quite a few people here working on HPC, high-performance computing, and they have software deployment issues, and they have reproducibility issues. So people are, becoming aware of this problem. They want to have tools to allow them to deploy their software more quickly on clusters and such, and they want to be able to run their experiments, months later. So they're starting to get more and more concerned about reproducibility, which was, I guess, not so much the case until recently. So that's it for the introduction. How should we proceed from now on, Daniel? Let me know.
Yeah, thank you. So I guess it could be nice if we go around everybody who may wish to say anything about themselves, because I think several people here are relevant to the story. So if that is okay, then could you please politely present yourself, if you wish, and tell just like a few words about who you are and why you may be interested in this talk. So who wants to begin?
And I go next. Yeah, so I'm Martin. I work on Next Journal, and yeah, we're very interested in providing better reproducibility for people, and I think this is the whole reproducibility problem is it's a lot being talked about in science, but it's actually a problem that every computer user constantly experiences when people just can't get software to work as it should or to install. And yeah, I feel like that we've sort of reached a local maximum with the old solutions to this problem, or even the newer solutions like Docker. And yeah, I'm pretty excited about like these principled approaches that Gigs and Nix like applying these functional principles to dependency management can bring, like in terms of a much better user experience and caching and performance down the road. And yeah, so pretty excited to learn more about Guix-Jupyter today.
Wonderful. Thank you, Martin. And who else may wish to present themselves and how they may relate to this story?
Maybe I can jump in. I'm Claus Harbo. I have a background in computer science. I work as a consultant. I have my own company, and I work mostly in pharma and regulated industries. I'm also quite interested in reproducibility. When you work with people with solutions where people's health is on the line, you need to deliver so-called validated systems, and it's a big and very costly thing to understand exactly what systems do and make sure they continue to do so. So I'm quite interested in that subject overall. I'm also the maintainer of Guix-Jupyter, which is one of the kernels for Clojure and Jupyter. So I'm super interested to learn more about Geeks.
Thanks. Thank you so much, Klaus. Anybody else wish to present themselves? Okay, thank you. So everybody are very modest. And so I guess we could begin. And so if that is okay, then Ludovic will give a talk about Guix-Jupyter, and then afterwards we will have a discussion. So Ludovic, your turn.
All right. So yeah, the way I thought about structuring this meeting is by starting with some sort of a talk. So I'll explain the rationale and everything about Guix-Jupyter, and then also make some live demos if everything goes well. And then we can make that interactive. So if you have any question, you can also interrupt me at any time, and I'll try to answer your questions. That work for you? All right. So this is the first time for me. I mean, this whole web meeting format. So I do my best. I hope everything is gonna work as expected. Let's see. So I will share my screen. So let me see. Need to click on the right things. This one. Okay, so you should be seeing slides instead of my face now. All right, so let's see. So how did I start looking at Jupyter? So actually, I'm not really a Jupyter user, at least not initially. I'm starting to use it, to be honest. I'm very much interested in Jupyter because with a Lisp background, as you people probably know it, I mean, Jupyter is something we're quite used to under a different name. We call it a REPL, right? But that's pretty much the kind of tool that real Lispers like to use. And so I've been, like I said before, I've been following all the work that's being done in terms of reproducible science lately. And I've heard more and more about Jupyter in the context of reproducible science. So, for example, there are quite a few. There are lots of tutorials on the web on how to do reproducible science. There are MOOCs, online courses. Lots of things mention Jupyter as a way to work towards reproducible science. And I think that's very good because we used to have those, those static papers, which were PDFs with figures and everything in there. People start to understand that as scientists, we need to be able to actually reproduce what's in the paper. And so we need not just the narrative, but also the code that led to those conclusions. And so Jupyter is a great progress in that direction. So I'm very much enthusiastic about this particular use of Jupyter. And again, things like Next Journal go in the same direction. And I think that's very good for reproducible science. But then, like I said, I've been working on Geeks for a while, and Geeks is about, let me see, still juggling with Windows. Geeks is about reproducibility, right? It's about being able to reproduce computational environment, a software environment. I started wondering, to what extent is Jupyter really about reproducibility, right? So of course you can have code, you can run it, and you can produce figures and all that, and that's great. But to what extent is that code actually reproducible? So for example, when I see a Jupyter cell like that one, I hope you can read it. So this is a Python cell in Jupyter Notebook. And when I see that, with my Geeks background, my first reaction is that, is that really reproducible? Am I really going to get the same result as you on your computer if I run it on my machine? Like, for example, the first line of that cell is matplotlib, right? So the assumption of that cell is that I have not only Python installed, the right version of Python, so probably Python 3, I guess. I also need to have matplotlib installed, and again, the right version of matplotlib, so that I can actually use this API. Otherwise, it's not going to work, or I'm going to get a runtime error, or I'm going to get a different result, that kind of thing. And to me, with my Geeks background, it's really a problem. You want to be able to make sure that you can actually run that code and get the result that the author intended to produce. And so that's the problem I and my colleague Pierre-Antoine Rouby set out to address through Geeks. So again, we've been working on Geeks. So when you have a nail, you see hammers everywhere or something like that. And so we wanted to see how we could take advantage of Geeks to introduce reproducible software deployment to a tool like Jupyter. And that's what we've been doing. So this example before was just a simple one, but turns out that when I started researching this issue, I realized that people would actually do things like run pip install directly in their Jupyter notebook, so that they could sort of make sure to some extent that they would get the right software environment for their notebook, which is indeed a bit scary, because you end up running basically arbitrary code on your machine as you execute the notebook, and you actually download arbitrary code from the internet. That doesn't sound great. It doesn't sound very much reproducible either, because you don't really know what you're going to install, because that depends on the time at which you run that pip install command, for example. So that sounds problematic.
The Clojure users, we are well aware of the problems of mutation. So I think most of us are already there.
Right. Most of you are already familiar with the issue, you mean? Right. All right. So yeah, again, so people would use pip install, or they would use conda inside their notebook, things like that. And I thought, this is not really going to work in the long term, right? Conda is not really good at reproducing software environments in the long term either, so that doesn't quite work. And then the solution that many people have started using is Binder. So Binder is both a bunch of software packages and a service, a centralized service at mybinder.org. And basically, you can give it a Git repo with either like a setup.py file or things like that. And it will create a Docker image based on your setup.py file or on your Docker file. And then it will be able to run your notebook inside that Docker image, which is pretty cool. But again, it's not really addressing the core problem, which is that the notebook itself does not contain software deployment information. So if if I write a notebook and I share it with you so that you can actually run it on your laptop, while you still don't know what to do to run it in the right software environment, that's kind of a problem. So instead, people share complete binder images roughly, so that they can actually, make sure they run the notebook in the right software environment. Right. So this is a list of instructions recognized by binder and by repo to Docker, which is the software that underlies binder, roughly. So the question we ask is, what if notebooks were self-contained? What if they were deployment aware? What if we could directly introduce software deployment information inside the notebook? So that if I share my notebook with you, well, it's self-contained, you can run it, and you'll be sure you're running software in the exact same environment as myself. And that's how we started Guix-Jupyter. So I just say a few words about Geeks. Right, so Geeks, for those not familiar with it, is you could view it as a package manager, or you could view it as a provisioning tool for container images, or as a distribution. There are several ways to approach it. But basically, it provides a bunch of command lines that allow you to create software environments or to create images of software environments. So the Geeks environment command that we see here creates on the fly an environment that contains precisely the package that you gave on the command line. So here I'm saying I want an environment that contains Python, NumPy, SciPy, and in that environment I want to run Python 3, the Python 3 command. All right. So that's pretty much the kind of software environment control that we want to have for Jupyter notebooks as well, right? And so we thought, how could we somehow add that capability to Jupyter notebooks? And that's the whole story, the whole theme, which led us to Guix-Jupyter. So I wrote a blog post a while back, which maybe some of you saw, about the story behind Guix-Jupyter, which is roughly what I'm explaining here today. So how did that work? So maybe let me do a couple of quick demos. So I need to share screen again. Or do we have any questions so far? Okay. So just quickly preparing the demo. And sharing screen again. All right. So can you see something here? Yeah, this is my Emacs shell. All right, I hope it's going to be readable. So what exactly is Geeks? So just very briefly, so we get a shared understanding of what Geeks is about. So like I said, you can view it as a package manager. So you can run Geeks, install, let's say, Clojure, all right? And then it behaves like a regular package manager. Oh, it's telling me I don't have much space left on my laptop. But now I've installed Clojure, right? So if I do Geeks package -- list installed, then I see Clojure, all right? I also actually need to install the JVM if I want to be able to run Clojure. So I need to install the ICE package, which is basically OpenJDK. And from there, I can do java-jar Geeks profile /share/java /closure.char, I guess. And I should be getting my closure repo from here. It's taking a while. Okay, here we go. And I have my repo. Great. So from that point of view, it's not so different from a regular package manager, except that if we look at what I've done, so I've run 2 Geeks install commands, and now I can run Geeks package -- list generations. And here we see 2 generations listed, right? So the first one has only closure installed, and the second one installs IST on top of closure. And that's why we see that plus sign at the beginning of the line here. Okay, so that means I can roll back to any previous generations and that kind of thing. But more importantly, what's very different from usual package manager, except Nix. So I don't know if people here in this meeting are familiar with Nix, but I should say that Geeks basically implement the functional deployment model of Nix, right? So some of the things I'm describing here obviously apply to Nix as well. Others not so much. I mean, some of the APIs and tools are different, for example. But yeah, this is the benefits I'm talking about here are really about the functional software deployment model that was pioneered by Nix. And so one thing that's very different from regular package managers is that there is very good provenance tracking, right? So if I run the Geeks describe command, for example, it tells me which Geeks I'm currently using. So Geeks itself is developed using Git. So here Geeks describe is telling me that I have one channel, what we call channels, which is the official Geeks channel, and it's telling me precisely which commit I'm running. All right. So if somebody else wants to run the exact same Geeks to install, then the exact same closure and the exact same JVM, then they can start from that commit, and that's all the information they need basically to be able to reproduce the exact same environment, bit for bit. So I like to say that this provides the same, the same advantages of Docker images containers, because you have bit for bit reproducibility. But at the same time, you still get the advantages of traditional package managers, and in particular, you have very detailed provenance tracking information. So you can always know how to reproduce a given software artifact, right? And that's a significant difference. All right, and then, yeah, again, like I showed before, if I want to create a Python 3 environment, I can run Geeks environment like this, which creates an on-the-fly environment with Python 3, right? And now I have Python 3. Can do things like that. All right, so much about Geeks itself. And all right, then going back to Guix-Jupyter. Again, do interrupt me if you have any questions. Although we can also discuss afterwards. Okay, so going to Guix-Jupyter now. Okay, so the window you're seeing here is my browser connected to a Jupyter notebook running on my machine. Okay, so let me know if I should zoom in a bit more. I don't know to what extent that's readable or pixelized. So in Jupyter Notebook, we have this new button here, which allows you to select a kernel. And essentially, when you're using Guix-Jupyter, you have a new kernel. So normally, you have a Python kernel, you have the Scicloj kernel, for example, you have the R kernel, and so on and so forth. And Guix-Jupyter is actually also a kernel, right? So you can say new notebook with the Geeks kernel. And this is it. You get a new notebook with the Geeks kernel. So as many of you, I guess, know, Jupyter Notebook is associated with one language. So when you create a new notebook, it's normally associated with one specific kernel, so one language. But when you select the Geeks kernel, instead you get some sort of a meta kernel, which will allow you to first choose what environment you want to use, what software environment, and what kernel you want to use in that environment. So let me give an example. So this is my, my Jupyter Notebook cell. I can introduce a special Geeks kernel annotation, and then I can say Geeks environment. Let's assume I want to create a Python environment. I call it Python, but the name does not really matter. It's only used internally in the notebook. Oh, actually, I should say that I wanted to use the Guix-Jupyter kernel, and I realized it wasn't packaged yet in Geeks. So I started looking at it yesterday and made some progress, but it's not there yet. So maybe we'll need to discuss afterwards to actually have it. That would be great.
Yeah, I can just add, if you need anything, let me know.
Sure. Yeah, all right. So anyway, for today, I'm sorry I start with a Python example. So I'm creating that environment, which I call Python, but then I need to specify which packages I want to use in that environment. So we will need the Python kernel at least. What is it called again? I always tend to forget. It's ipykernel. Then we need probably, let's say, matplotlib, right? And so from there, I'm creating that environment. So I enter the cell, and then in the background, the Geeks kernel is creating that environment, right? And then it's telling me, all right, I've chosen the ipykernel package, which is current in Geeks, so the 5.1.3 version, and my matplotlib as well. And from there, I should be able to type in Python code, I think, or maybe it's still creating the environment. So what the kernel needs to do in the background is to actually, actually ensure that these packages are available so that they are built and available locally, and then to actually start the Python kernel itself that's coming from that ipykernel package. All right, so now I can actually run Python code. So this 2 + 2 is Python code. I can do things like import matplotlib, right? Even with completion. And then, so I'm not very good at Python, so I cannot really show you a whole lot of code in there. I know about this, for example. This is my UID, well, the UID of my kernel running Python. That sort of stuff. All right, so the key takeaway here that we've created the Python environment right at the beginning of the notebook, specifying which packages we wanted to have in that environment. And then we get precisely those packages. And then we run code with the kernel that we asked for. And that's very different from the normal way of using Jupyter notebooks, because this time the notebook is pretty much self-contained or almost self-contained.
I'm curious if the provisioned environment is a throwaway thing that's discarded after the session, or cached locally at the machine, or how would that work next time you open this document?
So the environment is it's a throwaway thing in a way, but it's cached. So in Geeks, and actually that's inherited again from the Nix package manager. So every time you build something, like you build a package, the result of the build is pretty much cached in a special directory which we call the store. So for Geeks, that's under /gnu/store. And in terms of, in functional programming terms, it's basically memorization, right? So I guess I'll talk again a bit about it later, but basically we're viewing build processes as functions. So what that means is that concretely, the first time you create an environment with, let's say, Python for, Python, Matplotlib, and so on and so forth. But normally the next time it's going to be pretty fast, because it's already so this Geeks environment annotation in notebooks is already an improvement, in my opinion, compared to normal notebooks. But we could still do better. So I don't know if you're familiar with that movie. it's from my time, maybe not from yours. Maybe people are too young to know about Back to the Future, sorry. But I like to say that Geeks allows you to travel both in space and time. So it allows you to travel in space in the sense that you can deploy the exact same software environment on different machines, like on different clusters, or on your laptop, or on someone else's laptop. But it also allows you to travel in time, which means that you can actually say, all right, I want to recreate the software environment that was current like 6 months ago. And that's where it becomes interesting. So that's a second annotation that we've implemented in Guix-Jupyter, which we called Geekspin. So let me give a quick demo. Need to select the right window. All right, so I'm back to my browser. This time I'm switching to a notebook that already contains all the relevant pieces of information. So for example, I have my notebook, but if I really want to be complete, to really completely describe the software environment that I want to have, it's not sufficient to have, that Geeks environment annotation that I showed before, right? Because, for example, today's Python package in Geeks is Python 3 point something, but in a year from now, the default version of Python will be, I don't know, Python 4 maybe? Who knows? Yeah, it's a hot topic in Python. Major versions are a hot topic in Python, and I hear. But anyway, so the default version that's packaged by Geeks obviously changes over time, right? So that Geeks environment annotation is not sufficient, right? So if I really want to fully describe my environment, I also need to say which Geeks revision I'm using for that notebook. And that's where the Geekspin annotation comes in. So if you remember, just before I showed you that Geeks describe command. So Geeks describe, when you're using Geeks on the command line, allows you to see exactly which revision of Geeks you're using. And here Geekspin is sort of the dual of Geeks describe, because Geekspin allows you to say, all right, I want to use a specific revision of Geeks. So here, this is my Geekspin annotation. Let's assume I found out that this particular commit ID is working for me, and I want to make sure that my notebook will always be run with Geeks from that commit. Then I can enter that Geekspin annotation, and in the background, Guix-Jupyter instantiate Geeks from that commit. All right. So then it said that it succeeded, and if I follow this link, it's basically pointing to the web view of the commit I'm using, which is a commit from January last year. All right, so this time, all the Geeks annotations I'm going to have from now on in my notebook are actually going to use this specific revision of Geeks.
But when you say this revision of Geeks, does it mean only the package manager or also the packages themselves as they were seen by the package manager?
Right, it's really both. So it uses this specific revision of the package manager, but the package manager is what allows you to actually install the software packages themselves, right? So for example, back in January, Geeks would provide, I don't know, Guile 2.2.4 maybe. And so if I ask for that revision of Geeks and then I ask for the Guile package, I'm going to get Guile 2.2.4. And it's whole dependency graph from January last year.
And it cannot give you the Guile, which is, for example, later after, like if it's 3, then it can't give you the Guile 3 because at that time there was no Guile 3, for example.
Right, exactly. But I could have several cells using different revisions of Geeks and thus different revisions of Guile, for example.
Okay.
And could you also specify the version of Guile you want to use, like Guile 2.1?
Not directly. So usually in Geeks, in many distros, there's only one version of a given package available at a given point in time. So there are some exceptions. So for example, for GCC, we have several major versions available. For Python, we have Python 2 and Python 3 currently. But usually there's only one version of a given package. So for Guile, there's only the latest stable version. And that's why you actually need to go back to the previous revision of Geeks if you want to use older software. I guess that's different and also a very different way of approaching things compared to some other tools that try to provide, to leave some degree of liberty as to which version of a package you're using. The approach in Geeks and with functional package management is that you declare the whole package graph of a given package. So you probably don't want to maintain 10 versions of a given package all the time, because there's a lot of QA work that would need to be done, right? So that's how it works.
Or do you want to, is it okay to dig deeper into this now, or do you want to continue?
Sure, I'm happy to answer questions. Yeah.
Because that's what I see from a user perspective. Or could other people try to mute themselves? I'm hearing an echo. Users usually specify, when you work from with Geeks from the get-go, this might be fine this way. But normally when you're trying to reproduce already existent work, then you have all these declarations of what people are using, in requirements.txt files or in deps-eden files in Clojure. And would it be possible, I get that this is it depends a lot on the library, like a Python library that depends on system libraries is obviously much harder to get different versions going, whereas for a Clojure dependency that's just a jar, this might actually be pretty simple, right? To build something to bring in different versions of Maven packages and support all declarations that there are. Can you go a bit into that?
So I think it's in the end it's really a matter of policy in a way. For the core Geeks packages, I mean, for maintenance reasons, we want to focus on one version. But then Geeks allows you to have third-party channels, what we call channels, where you provide additional packages. And so, for example, we have someone working with the Coq Proof Assistant who wrote a channel with many different versions of Coq because they want to be able to test their software against all these versions. So that's something you can always do as a separate channel. And then Geeks also captures the specific revision of that channel that you're using. So if you're using Geeks with several channels, then Geeks Describe is going to show you the revision of each channel that you're using. And then you can reproduce again the exact same Geeks instance with the same channels. So that's one way you could address it if you have specific needs, like where you want to make sure you always have several versions available for a given set of packages.
Okay, and this version would have to be in a package name then, like you need some kind of mapping then.
Right, so Geeks allows you to have several packages with the same name and different versions, and then on the command line you can say I want that package at that version. So that's also supported in Guix-Jupyter. You can say Python at 2, for example, or things like that.
All right, and lastly on this, like specifying like what people are used to, there's Geeks import that kind of maps from these other declarations.
Right.
Geeks definition, right?
Yes, exactly. So Geeks only knows about packages available as well as Geeks packages. So if you have software available as a via, for example, pip for Python or that kind of stuff, then you first have to convert it, so to speak, to a Geeks package. And the Geeks import tool that you mentioned allows you to do that quite easily. So it's semi-automatic.
Right, thank you.
So you can import libraries from different programming ecosystems?
Yes, so we're basically in Geeks trying to subsume every language-specific package manager. That sounds ambitious.
Wow. That's really, yeah,
so it's obviously nice and not really doable, put this way. But we're really trying to to provide a tool set that's consistent and that gives enough of an incentive to be used instead of language-specific package managers. Because you're never going to use a single language in your whole stack, right? So you need tools that can handle software in different languages. That's my point of view. And that's why we have this Geeks import command that supports different common repositories like OPAM for OCaml, PyPy for Python, Crate for Rust, CPAN, Cran, all these things. It makes it quite easy in general to convert existing packages to Geeks. There is still a bit of additional work depending on the tool or the repo that you're using, but that's already an improvement. That's less work to do.
Right. Nice. Impressive.
Okay, so let me perhaps continue. I'm going to say a few words about the implementation. I think I'm hearing myself a little bit. All right, so I already mentioned the implementation a little bit. Maybe everyone, could you make sure that the mic is mute, because I hear a little bit of an echo? I think it's okay now. All right, so I talked a bit about the implementation, or you probably guessed already. Jupyter is so Guix-Jupyter is a kernel in Jupyter parlance. So basically what that means is that Jupyter itself, Jupyter Notebook, talks to Guix-Jupyter using the kernel protocol, which is JSON over 0MQ, roughly. We have a Jupyter kernel implementer in this meeting, so someone who's probably very familiar with it. And then Guix-Jupyter essentially behaves as a proxy to the actual kernel that you want to talk to. So every time Notebook sends a message to the Guix-Jupyter kernel, then the Guix-Jupyter kernel then relays that message to the right kernel. So in the example I gave before, I had a cell with the Python kernel, and Guix-Jupyter had started that Python process separately, and then was essentially forwarding messages from Jupyter to the Python kernel and back and forth, right? And the same happens with all the other kernels that you might want to use. Yes, so this is where I should talk about the execution environment of the kernel itself. So one thing that Guix-Jupyter does is obviously to set up the execution environment of the kernel, but it also runs the kernel in an isolated environment. So let me give an example. So because this is about reproducibility, we want to make sure that, everything, that your notebook is not going to interact with random things on your file system, for example, or with the network, things like that. And so that meant running the kernel in a container. So in Linux terms, it means using separate namespaces, if you're familiar with that. It's pretty much like a change root, chroot thing. So for example, if I go back to my Python example, or maybe that one has more. Right, that one is probably more complete. All right, so I'm recreating an environment with that IPy kernel package, though I guess I'm not using the same revision of Geeks, so maybe that's why it's taking some more time, I guess. Okay. So now I have my Python environment. I should be able to run Python cells. Oh, and by the way, this cell that defines the hello function here has again the Geeks environment notation, meaning that I'm explicitly asking Geeks to take the my IPython environment that I created above. So in this case it's redundant, but it's a facility that allows you to be explicit for each cell about the environment that you want to use, in case you have several environments in the same notebook. Okay. I don't know what it's doing. Maybe it's downloading something or whatever. Maybe I can go back to that one. Okay, so this is also a Python environment, so the one we saw before. And like I showed before, if I look at the UID of my Jupyter notebook process, it's 1000. Okay. And the good thing is that because the kernel, this Python kernel is running in a container, in separate PID namespaces, separate user namespaces, then you're always going to get UID 1000, all right, regardless of your host system. So this is entirely deterministic. And likewise, if I try to list what's available on my in my container, well, I have only these directories available. So /gnu is where the store directory is available. And then if I look at /home, Then I have only the Jupyter directory. And again, if I look inside that directory, up /home/Jupyter, then it's basically empty. All right. So what that means is that, we're running in a container, separate namespaces, a different file system view, and that ensures that my notebook cannot use things that happen to be on my laptop, right? So it ensures the notebook is going to be self-contained and is not going to refer to local files or even to the internet. So it cannot actually connect to a remote machine here because it's running in a separate networking namespace. And so it basically lacks network access entirely. So that's pretty good in terms of reproducibility. That's what we want to have. I think we want to make sure we only have access to, what's computed and what's specified in the notebook itself. Then
Can
again,
you enable network access?
Right, I was waiting for that question actually. So, right, so not having access to the network is obviously a problem. Usually you'll want to download data from somewhere so that you can process it, for example, things like that. So how do we do that? Well, we need additional facilities, right? We need to be able to download stuff. So for that, we introduced an additional annotation, which is this Geeks download annotation that you can see here in this cell. So it's pretty much like a normal download, right? Except that you have to specify the expected hash at the end, right? So the SHA-256 hash. And so that ensures that when you run the notebook, you're going to download this file from this URL, but it has to have this hash. And if you get a different hash, then it's an error. You cannot go any further, right? So I can evaluate this cell. Well, it's going to download it. I don't know how fast the network is in this room. But yeah, it's ensuring again that you're really getting what you initially intended to get here.
And would this also be cached in the store?
Right, this will also be cached in the store. So the store is all about caching, right? It's all about memorization. So I'm guessing it's being downloaded. Demo effect, right? Right. So anyway, this is the basic way, the basic approach that we have for Guix-Jupyter. So the thing here is first to have people be able to describe precisely the software environment that they need, and then also make sure that they describe precisely the external resources that the notebook needs. All right. I don't know, it's still processing. I'll go on and we'll check later, I guess. Okay, so this is actually, if you've ever read about Nix or Geeks before, what we're doing it is essentially an extension of the work that had been done initially for Nix and also implemented by Geeks. So this is a very good paper. I really recommend it, by Elko Dalstra and his former colleagues, about the inception of Nix, essentially, and the functional software deployment model. And essentially, we're here implementing the same model, roughly, but in the context of an interactive environment, which is Jupyter Notebooks, right? But the ideas are pretty much the same, only translated to the context of the interactive notebook. And yeah, I think that's pretty cool. So from the viewpoint of a functional programmer, this is, I think that's quite easy to understand. We want to view notebooks as pure functions. So they take input and they produce output, but there are no side effects, no undeclared inputs. So with this Guix-Jupyter kernel, with the additional annotations, the idea is that the notebook can really be viewed as a pure function because everything, all the inputs are declared in the notebook itself. That's the idea. So I'm going to wrap up for the talk, and then we can go in discussion mode, I guess. So there are obviously still some open issues. So this is pretty much a proof of concept. I mean, it's working, it's usable, but there are things that are that could be improved, like the user interface. So for example, we saw the Geeks pin interface before. It's great, it does the job, but as a user, you'd like to be able to say, all right, for example, I want to use the first commit where the Python version was number 3.x, something like that. So I'm sure we could improve the way you specify, for example, the Geeks revision that you want to use. Because using that SHA-1, that Git commit ID is convenient if you're already using Geeks, maybe, but if you're not into Geeks, that's not the best user interface. Another question, so we implemented it as a Jupyter kernel, but the question is, should deployment be built into Jupyter itself rather than be a separate thing that kernels or tools like Binder implement? I guess that's an open question. There are arguments in favor of keeping it separate from Jupyter itself. It provides more flexibility. You're not tied to a specific deployment tool, which is good. But on the other hand, software deployment should really be a central concern for Jupyter notebooks if we are to use them for reproducible science. So yeah, it's, there are pros and cons, I guess. Another question that people ask is about interoperability. So this is great. These annotations allow you to have a reproducible notebook, and that's pretty cool. But it assumes that people are running Jupyter Notebook on a machine that already runs Geeks, which, as a Geeks developer, I think it's a great thing to do. But still, that could be problematic from an interoperability viewpoint. So previously, someone suggested that we could add a Geeks annotation to automatically generate a Docker image from your notebook. So like you would have a semicolon Geeks pack annotation in your notebook that could generate a Docker image of your notebook, something like that. And I think that could be an improvement in that regard. And it's actually a low-hanging fruit because Geeks has a Geeks pack command that can generate Docker images or Singularity images or plain tarballs. So again, future work, I guess. And so in a nutshell, Guix-Jupyter is about making self-contained notebooks that can actually be reproducible with automatic and reproducible software deployment, and also code running in isolated environment, again, to make sure that it's as reproducible as it could. All right, this is it for the talk part of this meeting for myself, but I'm happy to answer questions now. Any questions left unanswered?
Thank you very much for the talk.
Yeah,
Thank you.
All right, may I go with
Thank you very
the
much.
question then?
Sure, go ahead, Martin.
All right, yeah. Thanks a lot. Also, yeah. So, if I may, like my outline, like the dream I would have about dependencies and maybe you can speak a bit to like if that's ever attainable and like how it would fit within the goal of Gigs. So like as I said, I think it's quite critical, like in order for people to like currently this requires quite a bit of buy-in from people, and they need to change like all of the commands and tools they know don't work anymore, right? And also all the description files. So like in my ideal world, like people could continue to use the descriptions that that they've used in the past, like requirements.txt, like deps Eden, and other descriptions. I think people care like more about the like exact versions of libraries that they're using than like things further down the stack like GCC and stuff. I think for this, like the distribution, like what you're currently doing is fine, but when we go further down and also like
and the way we could help with the setup phase is if it's easy to generate a Docker image, for example, for your whole Jupyter notebook that includes Gigs, like you would have a button roughly to generate an image that includes Jupyter, your notebook, Gigs itself, so that you can easily pass that image to someone who does not run Gigs, and still it's easy to use it, right? That's one approach, I guess. You also mentioned proprietary software. So GNU Gigs as a project is obviously not about proprietary software, so it does not provide any non-free software package. But you can have your own channels providing non-free software packages. That's something you can do. Some people do it. I would actually argue that from a reproducible science viewpoint, using black boxes is not a great idea. I mean, you want to be able to know what software you're running, what it is that you're doing, and to me, that's a problem to rely on black boxes for that. But I do understand that some people do it, and because in their field, it's very common to use. I mean, if you want to use GPUs, like you were saying, you have to use that NVIDIA thing, for example. Unfortunately, I hope it's going to change, but that's one case where NVIDIA is a situation of in a monopolistic situation, essentially. So, what else? You also mentioned macOS and Windows, I guess, in the same vein.
Or I mean, maybe even easier way maybe to also like provide Docker images to get started with Gigs that then also run on these platforms would be probably a much easier first step, right?
Right. So it's actually ironic because the project does not provide any official Docker image for Gigs, for example, but we do have tools that make it very easy to generate Docker images. So I'm sure we could do better and provide an official Docker image. That's something we need to work on, and it would make it easier to get started, I guess. And so indeed, you could use it on macOS and on Windows. Probably, I'm not very familiar with Windows. I guess Windows nowadays implements the Linux syscall ABI with the Windows subsystem for Linux. So it may be that you can just take the Gigs binary tarball from the download page of the Gigs website and unpack it and run it directly on Windows. I don't know. I haven't tried, but from what I understood of the Windows subsystem for Linux, it's supposed to work out of the box.
And lastly, like what we tried, what I think, at Nexternal, we tried to mount the like keep a global store around and like mount that into like via NFS or some shared file system, like mount that into every notebook, and then the like it's currently it's quite a big problem, like with Docker images, like when you want to run them in the cloud, that you have to download them first, and these environments don't really compose, right? So whatever the order you install in, like, totally changes your layers, and then you have to download gigabytes of stuff with just some minor changes, right? And this is something that's would work much nicer in with Gigs, like mounting the thing. You don't need to download anything, and things just are loaded lazily off the network. And everything that's once been installed never has to be built by somebody else. Again, I think that can provide down the road quite a amazing user experience. But maybe like also the build server that you provide, like, would it be possible, or how many resources are there, and like how long do you keep stuff around there, or is that something that where you would also where more support could help, like to speed up the build times for old stuff, and keep a bigger shared cache around? Is that something where you could see making improvements to usability as well, just by adding hardware, basically?
So regarding the official build servers for Gigs, so the one we are currently using are sponsored by a research institute in Germany and the MDC, Max Delbrück Center, and they provide quite a number of build machines to us. Like, we have around maybe 40 build machines now, which is, depending on how you look at it, quite a lot, and not necessarily so many. But I mean, that's already I think a good number of build machines for what we have to build. And we also have tens of terabytes of storage available, starting from maybe last year, I think. So that's still quite recent. That's only a year and a few months, I guess. But that's we have quite a lot of storage already to store things from the past. That's not enough to store things from forever, obviously. But then, I mean, I suppose I know the Nix project, for example, is using Amazon S3 to store things for a long time. That's one option, but in the end, also, we're working on reproducibility, reproducible builds, and so our goal is to make sure everything remains reproducible, even if you actually have to build it yourself, right? We're also working with software heritage.
Sorry. The reproducibility is the one thing, but also the convenience of like running things quickly, right? I mean, it's great that it works eventually.
Yeah, I mean, sure, in terms of user experience, it has to be fast and the binaries have to be available. So currently all I can say that we can keep binaries for a pretty long time, but it's only since a year and a few months ago.
All right. Unfortunately, I have to run already. Thanks so much, everybody. For putting this on, and for taking the time.
Thank you.
Thank you. Bye.
Bye-bye.
Anybody else wishes to ask anything?
Yeah, I'm wondering if you could maybe talk a little bit about how you package for Gigs. And you said earlier that you looked at packaging Guix-Jupyter. That's not a problem we're solving now, but what does it entail?
All right, so what does it entail to package for Gigs? I can show a quick example to make that more concrete. All right, so this is my Emacs window, so let me see. I can look up the package definition for Clojure, for example. And to you lispers, it should be pretty nice and pleasant to see because it's full of parentheses. So essentially, a package definition in Geeks is purely declarative, and it's pretty much like what you would write with other packaging tools. So you declare the name version, the URL for the source, the commit you're targeting, for example, and then. So this one is not the simplest package. I should probably start with the simple package just to get a feel of what it looks like. So this is a GNU Hello package. And yeah, you get all the usual pieces of information. So one piece of information here is the build system, which tells you how you're going to build the software. So GNU build system means that you're using the standard configure, make, install sequence. And yeah, and then there are other build systems, like there's a CMake build system for software using CMake. There's Clojure build system for Clojure things. I guess I'm not sure exactly what it uses under the hood. And this is all, so this is all in Scheme. So at the same time, you have declarative package definitions, but it's all schemes. So you can use, in Emacs, you can use Geyser, which is a mode for Guile and Racket and Chicken. And you can use it to navigate your code, for example. So all these things that we lispers are used to, which is pretty good. Then I should, so this is an example of a package with dependencies. So this one is already a bit more complex. So here we have patches. Okay. And then here we have dependencies. So we have native inputs and inputs. So native inputs is about dependencies needed at build time, and inputs is dependencies needed at runtime, essentially. Then a package can provide arguments to its build system. So for example, if you want to modify the sequence of build phases, you can say, all right, I'm using the standard build phases, but after the install phase, I want to have a custom install phase, and that's a Lambda where you can do arbitrary things. So in this example, we're just patching the file name that appears in the egrep and fgrep scripts. That's for the grep package. Things like that. Previously, someone mentioned Geeks import. Right, so Geeks import looks like this. So for example, if I want to import the package, the PyPy package that's called It's Dangerous, it actually exists. I can run Geeks import PyPy It's Dangerous. And then I hope you can read it. It downloaded metadata from PyPy, and then it automatically generated that thing, that package definition. Usually for PyPy, for example, it works out of the box. Like you can copy paste that package definition and it just works. Then, depending on the upstream repo, you may have to make additional modifications to make it work, or it really depends. But for PyPy, it's quite reliable, for example. And there are quite a few importers that are supported. What's it called? Yeah. So there are so-called importers for GNU packages, for Nix, PyPy, cpan, Hackage, Stackage, Help, Cran, Crate, and so on and so forth. Does that answer your question?
Yes, thanks.
No Java packages. No Maven packages.
Oh, there are actually Java packages. So we have quite a number of Java packages. Well, Let me see. I can give you precise stats.
How do you import them? Like, yeah.
I think so. I think we don't have a Maven importer, so I suppose people wrote them by hand.
Okay.
So like we have 312 Java packages, which is probably not so much actually from a Java programmer's viewpoint. But we do have Java packages. That's what I meant to say.
Okay.
And we have only a handful of Clojure packages. I checked yesterday. And we don't have an importer also for Clojure packages. So that's definitely something we need because doing them by hand is not fun. So, but it's quite. I'm not very familiar with Lightning Gun, I think it's called, the Clojure package manager. Right? But
well, it's the most used one, but it's not the only one. Yeah, especially now there is a bit of a convergence with the package. It's like there's some tooling that came out, which is called from Cognitech, the people from Clojure. It's called Tools Depths, and it changes the landscape of package managing in Clojure, but we're still amidst the whole kind of evolution, new tools appearing and stuff like that.
Yeah, I think that for Gitlab to be usable at all with Geeks, it would need to be able to import from Maven and Clojure.
Yeah, I would love that.
Everything feels unstable today.
Right.
Yeah. So
oh, the cats! My God, nice cats.
Oh, yeah, you can see they were here all the time. And
wow.
Yeah. So I guess the official time of the meeting to end is in 10 minutes. And for now, we can chat. And it might not be on the YouTube edited version that we upload later. But if there is anything else that people here wish to discuss until we possibly find Ludovic, then we can talk. And yes, I was curious about Guile too.
I don't think Ludovic is here.
Oh, here's Laura.
Here's Laura, yeah.
Yeah.
Hey, Laura. Ah, here's Ludovic.
Hi.
Oh, hello.
I'm really sorry. I ran out of battery, which normally doesn't happen.
Oh.
Because, you know, it usually lasts for 4 hours at least, but I don't know what happened. I'm really sorry.
You
no worries.
Yeah.
I know you think.
So what were we saying again?
I think I was remarking that I mean, I can't help think about Gitlab because I think if using Gitlab with Clojure would probably mean Gitlab, and there are several ways you can use it today, and you can install it using Conda, and it will give you a clean Clojure image with Gitlab in it, but nothing else. And one model to use it is to dynamically load libraries in your session as you go. You can also build your own Gitlab and include anything you like and deploy that. But I think most people will use the other model. And so not only would I think as I see it, for it to be meaningful, we would not only need a way to get Gitlab in there, but it would also need somehow to be able to get access to Clojure libraries and probably ideally also Java libraries.
Yeah. So
and I'm curious to hear if anybody has other ideas, but that's how I see it.
So I think what you're saying essentially that we have a packaging problem, right? I mean, at least that's the way I look at it. So I think it would be great to have a bridge from Java and Clojure packages to Geeks. That's how we usually address that, because the benefits then is that you can you can actually take care of all your packages with Geeks with a single tool, which is quite convenient, and you get the properties that you have with Geeks, which include provenance tracking, reproducibility. So that's pretty nice. So in my opinion, it's nicer than mixing, Conda with Docker, with pip, that sort of thing. But obviously,
I agree completely. I'm not arguing in favor of that. I'm just sort of trying to state how I see what we would need to make it work in a suitable manner, right? Because we don't want to put Conda in there. That doesn't make any sense.
Right. So I mean, so for most languages that have language-specific package managers, we've written an importer like I showed before, and I think that's what we would need to do for Clojure as well, which is complicated by the fact that, like Daniel was explaining, that there are several tools. So Leiningen plus tools depth, that's the name of the other one, right?
Yes.
Yeah.
Which is the core.
Yes, but I don't actually. I just realized that I don't think you need to support any of the Clojure tools. You need to support Maven. That's the only thing you need to support. The Maven repository, because this is how we work with packages. In Clojure, every package, every dependency is a jar. So what you need to specify is what jars you need, and I don't think you need to do anything for Clojure specifically. What you need is support for the JVM.
Right. So
this is what I suddenly realized. Why? Importing what exactly are you importing? Yeah. So if we import jars, then that's what Geeks needs to import as well. If my reasoning is correct.
Right. So obviously for Java, you can use jars directly. You don't have to go through Nix or even Conda or whatever. You can, like you say, you can directly use jars, and that's one of the big advantages of Java. For the Geeks project itself, we try hard to build everything from source, which means not reusing pre-built binaries such as jars. And I think that's important from many different viewpoints. It could be security, it could be transparency, reproducibility. That's very important, but obviously it's also challenging, and especially in the Java world, because like you say, people are used to sharing jars because it's so convenient. That's one of the big selling points of Java. But then it leaves a bit to be desired, because you can never really be sure where that binary jar came from, what its corresponding source is, and that's not ideal to me.
The Maven repository is useful. You know that one specific, like one version is always the same thing. It cannot be modified.
Right. You mean the jar itself that's available in the Maven repo cannot be modified? Did I get it?
They are, because they are it's an immutable store. Jars are specified by three components. There's a group ID, there's a name, and there's a version. Together they form a identifier. You cannot mix up, and you cannot modify after the fact jar.
Right.
Once they are published, that's it. That's so you know what you're getting. In terms of version, in terms of artifact.
Yeah. Another detail worth mentioning here is that typically Clojure jars contain the Clojure source code, and and not Java bytecode compilation of it. So
Yeah.
whether we could consider it as actually source code could be an interesting question. On the other hand, taking a jar and changing the code in it to create another jar is not an obvious task, at least in the current tool chain of Clojure. So maybe we need a way to depend on actual Clojure project source and not a jar, right?
Right. Yeah, I think so. So, for example, for the Clojure packages that we have in Geeks, we actually build them from source. I don't remember the specifics because I'm not the author of that part, but I think it's important in general to be able to, to rebuild by yourself and verify that you get the same binary as the official binary, for example. We are very much involved with the reproducible builds effort, which is available at reproducible-builds.org. And yeah, I think it's very important security-wise, in terms of transparency also, in terms of reproducible science also, because you want to make sure you're running the code that you think you run. But yeah, so I didn't know that Clojure jars usually embed source code as well, so that's obviously an improvement. It makes it easier to verify the .class files, I guess.
Yeah. Now it is like the official time of end of the meeting, and I guess it depends on you if you wish to stay a little bit, or if you can, then that would be lovely. And otherwise, we can take it as the moment to end the official video, and then anybody who wishes to stay can keep chatting. So what do you think? Would you like to continue a little bit more, or maybe you need to go to another thing?
I guess I need to go within 10 minutes or something. So maybe if there's one last thing you people want to discuss, I'm happy to discuss it. And in 10 minutes, I'll be going, I guess. Or I'll be going
beautiful.
now. Yeah.
So anybody, Klaus or Daniel?
We're happy to get a couple of minutes with Ludovic. I was wondering how the project is evolving. Because I'm following the projects from a distance, and I, as someone who appreciates both Guile and what Geeks does, I wonder how, for example, since last time I heard you in Nara in Japan, that was 2 years ago. Or no, actually more. I think maybe 4 years. I don't know, 3 years. When was this? I don't remember. Anyway,
4 years.
Okay. So how what is changing? How is the project evolving? Do you manage to get people on board? Do you manage to get the resources you need? Do you have a clear direction? Are you happy with how the project is being adopted, the adoption rate being understood? I mean, I would love to hear you talking about that.
Yeah, well, so there are many things happening every day. So for me, as one of the maintainers, it's a bit challenging actually to follow everything. Well, I don't have to follow everything, but I'm interested in many of these tasks. So we've definitely seen more people adopt it. We've actually released a 1.0 release last year in May.
Right.
And it had been 7 years of work, so I'm really happy we reached that milestone. And now we keep going. We still have a lot to do on our plate. So, for example, over the last few years, we've been more and more involved with reproducible builds, and also with bootstrappable builds, and actually other Guile and GNU hackers starting working on, and non-GNU hackers too, started working on bootstrappable builds, which is about making sure that we build everything from source down to the compilers. So if we go deep down to the root of the dependency graph, being able to build that from source to some extent. Or another way to put it is being able to use as few binaries as possible as sources, you know. I think that's again very important work from security and transparency and user freedom viewpoint, and I'm really happy people started working on it. Yeah, so that's one example. Then we've had lots of improvements in many areas for the standalone distribution that we call Geeks system.
Yeah.
So we've had people work on writing new services, writing a graphical installer, so like pretty much like that of Debian, similar kind of thing. We've had many improvements to the UI, to the command line interface. There's an Emacs interface also that's been evolving. Yeah, then there are side projects like this Geeks HPC thing, where we focused more specifically on reproducible science and yeah, high performance computing. Well, we've had also changes like channels, you know, core changes, I would say. Well, yeah, lots of things. And we get more feedback, which probably means that adoption is rising, I guess.
And what kind of people are coming to this project? Who does it talk to most?
Well, so I guess there are many individuals like GNU Linux savvy people, I would say, or people interested in user freedom, things like that. And then there are more and more people interested in reproducibility. So people who were familiar with other package managers, for example, and probably got tired of their shortcomings in terms of reproducibility. And so we get actually lots of people who are not familiar with functional programming, but just want to be able to use, you know, to have those facilities like transactional upgrades and rollbacks, you know, that kind of thing. Yeah. And it's interesting because even all the people who write new package definitions, most of them are not schemers or even Lispers.
Right.
Which I think is interesting, you know. So, you know, initially they start like by writing simple package definitions because, you know, it's purely declarative, so you don't have to be an expert in scheme to understand what's going on. And then they start writing actual scheme code without really, you know, noticing, I would say. And that's the evil plan, actually.
Yeah, nice. Nice. And how is I mean, in this space of functional package management, you are there with Nix, and how do you fight among yourselves? How does it go? Like,
I mean, Nix versus Geeks.
Yeah.
Oh, I don't think we fight among ourselves. I mean, we regularly meet actually. Like
for users, I mean. For you, it's not
no, like, for me, it's definitely not a fight. We have, so the two projects are similar in the sense that they both implement the functional software deployment model, and that sets them apart from pretty much everything else, right? But then we have different approaches to many things, like the UI is very different. And as you know, the internals are very different because we chose to provide a unified scheme interface to basically everything, whereas Nix has, you know, this specific domain-specific language that's called the Nix language, plus lots of Bash scripts, plus C code, you know, lots of things. So it's, yeah, I guess, I mean, these are two different projects, right? So the common thing here is functional deployment and reproducibility, but then everything else is different. We take different focuses also, so that's fine.
in reality, what kind of people will end up with Nix and what kind of people will end up with Geeks? How does that work?
Well, so for me, one of the goals when I started Geeks was to make Nix usable by normal people. So,
Okay.
so for example, in terms of the CLI, the command line interface, I think it's easier to use Geeks than Nix nowadays, although the Nix CLI has also vastly improved, I guess, over the last few years. But I really want it to be simple to use, so we're trying hard to work on the user interface, and that I think that makes a difference. If you've tried both, I hope you do see a difference. So that's one thing. And then also, if you're for tinkerers, and I would hope that most people would at times be tinkerers. You don't have to be a tinkerer all of your time, but in Geeks we really make it easy to see what's going on in your system, because everything is in one language. It's very easy to jump from one place of your system to a different place. It's sort of, to us Lispers, I wouldn't say it's a Lisp machine when you run Geeks system, because obviously we're still running the typical GNU userland, which is lots of C code, but still there's quite a bit of scheme code in there, like the init system is in Scheme. Everything to build the system itself is in Scheme. So that makes it really hackable, and to me very pleasant. I think to a Lisper it should be very pleasant.
Great, nice. Thank you.
Yeah, so I guess it is now 10 past the official time.
Yep.
And Ludovic, any last comments you would like to say?
Well, just thank you for organizing this meeting. It's been a bit bumpy at times due to technical issues, but I'm really happy that we were able to chat together.
Me too. Thank you so much.
Yeah, thanks a lot. Very interesting.
Yeah, I'm not sure, Ludovic, if you know how refreshing it was for us to have that glimpse of another ecosystem and those inspiring ways you use functional programming. And now it is for us the time to learn, to go and learn. And at least myself, I must now try to do some Guile and Geeks. And thank you so much for this. And it was magnificent.
So I hope we can stay in touch and discuss things like Guix-Jupyter packaging, or writing an importer for Clojure packages, things like that. I would be interested in discussing it further.
Great. Yes. I hope so.
Yes.
I hope
Let
we
us
move
talk.
on. Yes. Absolutely.
Yeah.
All right. Thanks a lot. Have a nice evening.
Okay.
Yeah. Goodbye,
Bye-bye.
everybody.
Goodbye.
Thank you so much.
Thank you. Thank you to all. Bye-bye.
Bye.
Bye. You have the t-shirt too. Good memories. Yes.